So principal value is just narrowing it down for you. So it says right here, I tried to give you a hint. It says, for example, if we investigate the sine function, we notice the range is 1 to -1. Do you agree with that, that the y values go from +1 to -1, right? You remember your graphs? Remember, sine does that because it's the unit circle. So as far as sine can go is 1, right? That's as far as it can go. And as far as the y value goes. So we want to find out, is there a part of its domain, meaning the x values or the degrees, that cover basically -1 all the way to 1? For example, we could start many different places, but what we could do, and I'll tell you what they do, but what we could do is we could start at 90 degrees. Do you see that that starts right up here, and that takes care of +1, correct? And if I keep going, it hits a lot of those values in between, and then it hits -1. So if I did just that much, have I covered every single y value that can happen or will happen in this graph? I have. And really, was that very long? That wasn't very far at all, was it? That was only 180 degrees. That was very quick that that happened. Okay? And so what they say for your principal values for sine, they don't actually use that one. Which one do you suppose they use? They don't use 90 to 270. Is there another place that you can hit all those values? 1 to -1, -1 to 1. Is there another place you can do that? Okay, you can do 0 to 360, but what we're trying to do is narrow this down as much as possible. And what they do is they just go from -90 to 90. Has every y value been taken care of in that short period of time? So if they ask you for the principal values, you better give them an answer. Basically, that's between -90 and 90. So should I give 180 as a principal value answer for sine? No. It better be between those two. Because I know that every single one happens at least once. Okay, in between there, and that's why we're narrowing it down. Okay. How about cosine? What's cosine's range? Range, y values. Yeah, isn't it the same thing for cosine? You have a very similar graph. I think this one's actually easier to figure out which one they would use. Obviously, could you figure out which ones you wanted to use? Yes, but then you'd have to tell me that before you did the problem. So this is the principal values that everybody is supposed to use. Again, you want every single y value taken care of. So where could you start and stop that would take care of that? What's probably the easiest place to do that? Yeah, 0 to 180. Isn't that pretty simple? If you just start right here, you got -1. And then you go on down, you got all these y values. You're hitting all those y values, and there's -1. And have I hit every single value that could possibly happen? Yeah, does this value say right there happen again? Yeah, it happens here, it happens here, it happens there. That's why we had to do that k thing before. Now you don't need k because I'm telling you, your answer better be from 0 to 180. So 0 and 180. So should you tell me -90 as an answer if we're talking cosine? No, don't tell me that. Okay? Find another place that does the same thing. That's between 0 and 180. So is your knowledge of the unit circle probably going to be somewhat important? Yeah. Okay. Again, this is for inverse trig, meaning arc sine, arc cosine. And the last one is tangent. Range is basically all reals. Remember that? Because it goes all the way up, down to the negatives, all the way up to the positives. What's probably the easiest place to talk about tangent? The easiest. I heard 0. I don't know if we're going to start at 0. We're going to go -90 to 90. Very good. We're just going to start down here. There's a bunch of them way down here, and we're going to get all of them all the way up there. Because remember, that's where the asymptotes are, right? So it is -90 to 90. So how some people remember it is cosine's kind of the oddball of the two. Sine and tangent, you notice, are the same. Cosine is 0 to 180. The other two are -90 to 90. So that's where your answers better be. Don't give me an answer that's not in that range if you're doing inverse trig, if they ask for principal values. Okay? And today I am going to ask you all the time for only the principal values. Really, all this does is it saves you time. You don't have to give me all the answers. Yes?
Would it be okay if you didn't put like the equal to sign on the top?
Very true. The question that was here is a great question. It says on the tangent, do we really have to have the equal to on the inequality? Because is it ever, if we ever really go to 90? Well, if I give you an undefined, then you might have to actually answer 90, but that's a great question. No one's ever asked that before. Okay? because I see exactly what he's thinking. Well, if you're not supposed to answer undefined, then why would you need 90? Well, you might have to. Okay. Let's see what we're talking about here. Let's start with a simple one. Arc sine of -1/2. Now, real quick, sine is, I like to write off to the side, has to be -90 to 90, right? That's where my answer has to be. Is that the principal range? Yep. And so what we have to do is say, all right, well, where is that? Okay, so we sit here and we go like this. So in other words, if it's saying -90 to 90, it's basically saying stay in those two quadrants, right? Isn't that really what it's saying? Stay in quadrants 1 and 4. And so is sine ever going to be negative in one of those quadrants? Quadrant 1 or quadrant 4? Which one will? It's going to be quadrant, right? Because sine's the y value, isn't it? So we know that it's probably either going to happen here or there, correct? Not at that 45. That's not going to happen there because we know that's negative square root of 2 over 2. So which one's actually -1/2? Is it up here at the 330, or is it down here at the 300? Are you sure? Yeah, because sine, it's the shorter of the two, right? If you drew in the triangle, it'd be the shorter of the two. So 330 degrees. Is that a good answer? Is that a good answer to this question based on the rules? Why is 330 not a good answer? Isn't that where it is? Yeah, but is it in this range? No. How are you supposed to answer it then? Negative? How far is it? Yep, -30. Very good. -30 degrees is the best answer to that if you're told to do principal values. Well done. Now remember, you only do this when it's inverse trig. So you look at letter B. Sine of pi over 2. Is that inverse trig right there? How do you know? Because there's no -1, right? There's no arc there. Is sine at pi over 2, is that something we can determine? Okay, so we go here. Pi over 2 is right there. And so this is, what, 0, 1? Do I have to worry about sine's range on this one if it's not arc sine? No, I just have to find out what the answer is. So sine at pi over 2, who knows that answer? Just sine at pi over 2, just this part. Do you agree it's 1? Right? So this is really asking for arctangent of, I can completely replace this with what it's equal to, which is 1. Do you agree that's asking the same thing? So now it's saying, where is tangent 1? Remember, that's how I look at the arc, is where. Where is tangent 1? Well, what's tangent's little range? Isn't it the same, right? It's -90 to 90. So where is tangent? So again, we're talking about that one and that one, right? We're sticking in these quadrants. So where's tangent? You're probably getting pretty good at this one as to where this happens. Okay. No, it's asking where. So where is tangent 1? 45 degrees. Does 45 degrees fit into our range? Yes, it does. Because it's square root of 2 over 2 over square root of 2 over 2, right? It fits into our range. Okay. Now you may notice why you got your little sheets back. Oh, yeah. Oh, look, arctangent of square root of 3. Oh, that might be helpful. Now, is this one, should I worry about the range for that one? For arctan, yeah, that's arc. I better worry about the range. And for tangent, it's -90 to 90. How about for this one that I just put the arrow to? Arc sine of square root of 3 over 2. Should I worry about the range for that one? Or should I worry about the values? Yeah, what is sine's values? It has to be between -90 and 90. What I want you to do right now is see if you can answer that question, and you can stop at that point, and we'll see what you get. Let's take a look, see how you did. Let's probably do arc sine of square root of 3 over 2 first, because we can just do that one pretty simply right on here. Sine, again, it's saying you got to go from here to here to give me your answer. Does square root of 3 over 2 actually ever happen for sine from there to there? Yeah, in the first quadrant or in the fourth? First, because it's positive. And we know it's probably either at 30 or 60, right? That's probably where it's going to happen. So it's where sine or the y value is bigger, and which one is that? Is that 30 or 60? That's at 60. So just this part of the question, because remember, arc means where, and it's going to happen at 60 degrees. So arctangent of square root of 3. So we want to know, where is tangent square root of 3? So where is tangent square root of 3? So you got to find square root of 3 in the tangent column. Okay, oh, here's cotangent. I almost looked at the wrong one. So you go over here, you look at tangent, you find square root of 3. Oh, it happened right here at 60 degrees. Did everybody see that? If you kind of put the two together, here's 60 degrees going right there, and there's tangent, right? So it's saying, so where is tangent square root of 3? Is 60 degrees in the range it's supposed to be for tangent? Is that in the right area? Yep, so 60 degrees. Okay, well, let's get out of here then. We know it's 60 degrees. So 60 degrees right here. So you agree, well, what should I put in between there? Oh, minus, yeah, because it says minus right there. So what should I do first? Should I find cosine at 60, or should I subtract the 60 minus the 60? What should I do first? Yeah, it's still parentheses, right? It's still telling you to do that first, just like it has since Algebra 1. So basically 60 minus 6, so it's what? Cosine at 0 degrees. Is this asking where cosine is 0? Or tell me cosine is what at 0? That's the big question. Is there arc involved here? No, it's just saying find cosine at 0 degrees. So we go over here to 0 degrees, and we find out at 0 degrees, cosine happens to be what? 1. Do you understand the difference between when there's an arc on it and when there's not? When there's an arc, it's asking where's it going to happen. When there's not an arc, it's saying tell me the value there. Okay, that's the big difference between the two.